Pluto is a remote and baffling, more humble planet that was once a piece of our sun-energized system's planetary assembly. However, later, amazing declarations by prominent astrophysicists Neil deGrasse Tyson and Michio Kaku have carried Pluto back into the spotlight with a surprising revelation. They suggested that this cold world is on a potential impact course with Neptune. But how could this happen, and what might be the repercussions of such a monumental event? Are we witnessing an intriguing cosmic phenomenon, or is there more to this impending cosmic clash? Join us as we examine the potential consequences of a Pluto-Neptune collision. Pluto, a former planet that was renamed as a dwarf planet partly because of its peculiar orbit, remains a subject of interest and study in the astronomical community. According to recent calculations by leading scientists, Pluto's orbit is dangerously close to Neptune's, with both Neil deGrasse Tyson and Michio Kaku sounding the alarm about a possible hazardous collision between these two celestial bodies, which could pose a significant risk to Earth. How is such an event even possible? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes an astonishing 248 years to complete a single orbit. Since its discovery in 1930, it hasn't yet completed one full revolution. However, the fascination doesn't stop there. Pluto's orbit is marked by its exceptional eccentric shape, differing dramatically from the nearly circular orbits of the major planets. What makes Pluto's orbit even more remarkable is its inclination, set at 17 degrees to the ecliptic plane. This extreme inclination and elongated nature add layers of complexity to its orbital path. One of the most fascinating aspects of Pluto's orbit is its intersection point with Neptune's path. For about 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, challenging what we might expect from their positions in the solar system. This raises a natural question. Why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to understand its unusual path. Unlike the planets whose orbits lie relatively close to the ecliptic plane, Pluto's orbit stood out with its steep inclination and elongated shape. The mystery deepened with the realization that Pluto's orbit indeed crosses Neptune's. The stability of Pluto's orbit amidst these complexities is evidence of the intricate design of celestial mechanics. The three-body problem in space involves determining how three objects, like Pluto, Neptune, and the Sun, move and influence each other with their gravity. It's like predicting their paths based on their starting points and how they pull on one another. In Pluto's case, this problem illustrates how Neptune's orbit and the Sun's gravity interact in a complicated way. The terms libration and resonance are crucial in this context. According to astrophysicists, libration ensures that whenever Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial separation is critical in preventing their orbits from colliding. Resonance libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned significantly above their orbital plane, adding another layer of protection against potential impacts. Another significant factor is a Vieske oscillation, named after researchers von Zeipel, Kapteyn, and Levi Civita, who studied how objects move in space. This oscillation helps explain why Pluto's orbit remains stable despite its seemingly erratic path. Predicting cosmic events, especially involving complex orbits like Pluto's, presents significant challenges. The inherent unpredictability of these systems means that long-term predictions often come with uncertainties. While mathematical simulations provide a robust means of understanding and predicting the future, paths of celestial bodies, they also highlight the limitations of our predictive abilities. Even a minor error or deviation can lead to vastly different outcomes, making precise predictions daunting. Despite these complexities, there is a general scientific consensus that, for the foreseeable future, Pluto's and Neptune's orbits remain stable due to their mean motion resonance and the various gravitational forces acting on them. Consequently, a direct collision between Pluto and Neptune is highly unlikely. However, the intricate orbital dynamics suggest that astronomers should continue to monitor and study these celestial bodies to better understand their long-term behavior and any potential risks they may pose. In conclusion, while the possibility of a Pluto-Neptune collision is largely theoretical and considered improbable with current understanding, it underscores the importance of continuous research and observation. Both Neil deGrasse Tyson and Michio Kaku emphasize that space remains an area of infinite discovery and that our current knowledge, while significant, is still limited. Their perspectives highlight the need for ongoing exploration and advanced modeling to refine our understanding of the universe and prepare for unexpected cosmic events. The case of Pluto and Neptune serves as a powerful reminder of the dynamic and ever-evolving nature of our solar system. It highlights the delicate gravitational dance that governs celestial bodies and the critical role of advanced simulations and observations in predicting their behavior. As our technology and scientific understanding continue to advance, we gain deeper insights into these cosmic interactions, but each discovery also raises new questions, pushing the boundaries of our knowledge even further. For Neil deGrasse Tyson and Michio Kaku, this ongoing quest for understanding is more than a scientific endeavor. It's a call to humanity to remain curious, vigilant, and prepared. Tyson often stresses that reclassifying Pluto as a dwarf planet wasn't a demotion, but a necessary step in accurately categorizing celestial bodies as we learn more about them. His perspective encourages us to see the universe not as a static system, but as a dynamic, interconnected web of forces that constantly reshapes our understanding of space. Similarly, Michio Kaku's futurist outlook emphasizes the broader implications of space events. He warns that even unlikely scenarios, such as a Pluto-Neptune collision, should not be dismissed outright. Instead, they should serve as catalysts for further research and preparedness. Kaku envisions a future where humanity might need to develop technologies to mitigate potential threats from space, such as asteroid impacts or planetary disturbances. This proactive approach is essential for ensuring our long-term survival and advancement as a species. Moreover, the study of Pluto's orbit provides valuable lessons about the broader cosmos. The intricate gravitational interactions between celestial bodies offer a microcosm of the forces at play throughout the universe. By studying these interactions, scientists can develop better models to predict the behavior of other systems, including exoplanetary systems beyond our solar system. This knowledge could one day help us identify habitable planets, understand the formation of galaxies, or even detect potential threats from interstellar objects. The potential for unexpected cosmic events also highlights the importance of international collaboration in space research. No single nation can fully understand or prepare for the vast and complex phenomena of the universe on its own. Collaborative efforts, such as those involving space agencies like NASA, ESA, and JAXA, are crucial for pooling resources, sharing knowledge, and developing comprehensive strategies to address potential cosmic threats. In the end, the hypothetical scenario of a Pluto-Neptune collision, while unlikely, serves as a powerful thought experiment. It forces us to confront the limits of our current knowledge and the need for continuous exploration. It also reminds us that the universe is a place of constant change and surprise. As Tyson and Kaku emphasize, our journey to understand the cosmos is far from over. Each new discovery brings us closer to unraveling the mysteries of the universe, but it also opens the door to new questions and challenges. For humanity, this means remaining committed to scientific inquiry, investing in advanced technologies, and fostering a culture of curiosity and exploration. The more we learn about the forces that shape our solar system, the better prepared we will be to face the unknown, and perhaps, one day, to venture beyond our planetary neighborhood into the vast, uncharted realms of space.